All right, lesson 2 of week 5. I promise this one will not be 39 minutes long. The last one was really long, but we can do it. All right, warm up like the last one. Try this one on your own. Pause the video and then turn it back on if you want to see how I do it. All right, here we go. So if you want to write this as a mixed number, it's actually pretty simple. It's just 5 3/7. But then if we want to write it as an improper fraction, the way you probably were all taught to do it is we take the 7, multiply it by the 5, we get 35, but then we have to add the 3 to it, and we put it all over 7. So we end up with 38 over 7. That's it. Not too bad. Now what we technically are doing when you do that 7 times 5, we're using a common denominator of 7. And if you want to do the 5 over 1 trick and find the LCD, you'll see that it's just 7 times 5 plus 3 divided by 7. Okay, so we got something like that to start off our first example here. So one thing you can kind of do maybe is to say, hey, if I just have a whole number and I am going to add it to a fraction, I just need to multiply that whole number by the denominator of the other fraction. So I'm just going to say, hey, this is 2 times b plus 3 plus the b that's in the second fraction, and then it's all divided by b plus 3. Okay, so that's kind of a quick way to think about it. It's kind of like 7 times 5, 35, plus 3. Okay, and then we just put it all over the denominator. And so then we just have to simplify a little bit here. So we end up with 2b plus 6 plus b. Now, problem. Hold on. I don't like the variable b. There's a 6, because they end up looking like 6s. At least mine do. Okay, so 2b plus b is 3b. So we have 3b plus 6 over b plus 3. And I was kind of hoping this would go somewhere, but it's not. So we can factor out a 3 up on top, but then we can't really go anywhere from there, so that's it. Okay? So when you're dealing with whole numbers, there's kind of a quick and easy trick for doing them. All right, so let's look at another one. So again, this is kind of similar to the last one, not this last problem, but last assignment, where we got to do a bunch of factoring. So let's rewrite these fractions when we factor them. So I'm going to factor out an x. So I have 2x plus 3. And then I'm going to factor out a 2 out of this one. So I have 2x plus 3. Okay, and so from an LCD standpoint, I have unique things are x, 2. Those are the same, so I'm just going to pick one of them. So my LCD is 2x times 2x plus 3. And then I'm going to rewrite my fractions. And so in order to create my fractions, what do I have to do to the numerators? While I'm writing this down, you could think about that. And maybe you have the answer. Okay, so the first one, the difference between the numerators and the first fraction, I just have to multiply by 2, so this becomes a 10. 5 times 2 is 10. And then in the second one, all I have to do is multiply by x, so this becomes 3x squared. And then I'm going to subtract. So 10 minus 3x squared all over 2x times 2x plus 3. And then this is one where I like to flip them around. Okay, and then I also like to maybe get that negative on its own. So I can come down here and write it as the whole fraction is negative. Oh, wait a minute. No. I have to factor out a -1 first, remember. So we have 3x squared minus 10 over 2x times 2x plus 3. I'm really encroaching on the next problem, and I'm not liking that. And then we could also just write it as, hold on, as an entirely negative fraction. Oh, I don't want that. Hold on. This is why the video is going to get long. Okay, actually, you know what? I'm just going to delete that. Okay, so then I could just write this as the whole fraction is negative, and it becomes 3x squared minus 10 over 2x times 2x plus 3. Okay, so all 4 of these, 1, 2, 3, 4, are equivalent fractions. And, you know, ideally the last one is where we want to be, but if you're at one of the other ones, that's not the end of the world. Okay? All right, so let's see here. C. I see. Gosh, everything's already kind of factored for us. We got a 5, we got a y, we got a denominator, binomial, I mean, that's y plus 1. We could do this so you see it better. And so my LCD is 5y times y plus 1. Okay, so then if I rewrite my fractions with 5y times y plus 1, and what do I have to do to the first one to turn it into 5y times y plus 1? Well, I'm multiplying by y plus 1, so I'm just going to write y plus 1 next to the 3. And then for the second one, I've got to multiply it by 5y, so I'm actually going to multiply, and it becomes 10y. Okay, and then we can add them together. Now, some of you might want to do the distributing step at the same time. That's fine, as long as you can keep yourself organized and not lose something along the way. Okay, so when I said distributing step, I mean right here. So we have 3y plus 3 plus 10y. This one isn't going to do anything for us either. All over 5y times y plus 1. And then combine like terms. We got to get somewhere we actually cancel some stuff. So we have 13y plus 3 over 5y times y plus 1. And that's it. And we got one more. Hopefully we can cancel something here. I don't know if we will be able to. We'll find out. All right. Oh, these right here. It's like, if you could see those really fast, that's great. Squareds. 9 is a squared. X squared is squared. And its difference. So we know that's 2 binomials. We know both of these are going to be 2 binomials. So we can go binomial, binomial. And it's x plus 9, not 9, 3. X minus 3. And then this one maybe takes a little more thinking. What multiplies to 12 adds to 7? Well, in my book, that's 3 and 4. So we have x plus 3, x plus 4. Okay, so then we identify our LCD by identifying what's unique, 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 and those are the same, so I take 1. So my LCD is x plus 3, x plus 4, x minus 3. Okay. And so I rewrite my fractions. Oops, wait a minute. Let's put those there so I can see them. Okay, so rewrite my fractions. And so I have all this. You know I'm going to do this. I am going to get creative. And come on, copy. Why is it not copy? There we go. Copy. Paste image. Make smaller. Put there. Paste image. Make smaller. Guys, gotta love that I'm talking through this. All right. And so then we have to think, okay, what do I do to x plus 3, x plus 4 to turn it into that new denominator? Well, I multiply it by x minus 3. So we have 2x times x minus 3. And what do I do to x plus 3, x minus 3? Well, I got to multiply it by x plus 4. So this one I multiply by x plus 4. Okay, and then we're going to add and do some distributing and all that fun stuff. And so hopefully we're going to get something we can cancel in this one, but we may not, and that's okay. And again, if you want to do the distributing at the same time here, you can. Paste image. There we go. So now I'm going to distribute. So we got a fair amount of work to do with this, but you know, it's not the end of the world. So we have 2x squared minus 6x plus 3x squared. Nothing again. We're not going to get anything out of this one. This is kind of annoying. All over. Paste image. There we go. You know, old-time math people, they would just be loving this because they had to write with chalk on chalkboards, and they can't do this pasting stuff. All right, so we're going to combine like terms, those, and those theirs. All right, so we have 2 and 3 is 5. Negative 6 and positive 12 is positive 6. Paste image. Make smaller. All right, and then the only thing we can do here is, again, we can factor out an x. So we could write this as x times 5x plus 6 over, paste image. There we go. You know, and neatness counts here, so let's move this guy over. Look at that. Whoops, I don't want to do that. Okay. So you guys have a few to try on your own, not very many. There is one nice challenge problem down here at the bottom where you have to find the perimeter and the area of a rectangle. So not only are you going to do what we're doing this week, you got to think back to what we did 2 weeks ago for finding the area. All right, questions, let me know.